In our last video, we built NAND gates. And then I said that we could connect them to create what's called a D-latch, which is 1 bit of computer memory. And I gave that to my students last time as a kit. They could assemble it if they wanted to. Well, we're meeting at the library again this Saturday, and I thought I'd explain to them how that circuit works. Well, at least show it to them working. I don't even know if I can explain how it works. But the idea is, with this circuit of 4 NAND gates, we can build it with one integrated circuit. I gave them that circuit, I gave them some wire and everything they needed to do it. So let's see how that works. Okay, here we have a D-latch made of 4 NAND gates that are inside that circuit. And this matches the same diagram I showed earlier with all the wires. It's a little hard to see what's going on. It's always going to be true on a breadboard. It gets a little tight. But I've used different color wires, and we can trace that next to the diagram to understand what's going on. I have a light here that's going to show us the data that this latch is holding. It's either going to be on or off. And I'm going to control that with these 2 different lines here. This one is the enable line, and this is the data line. So enable is on and data is on. So when we turn this on, the light should be on. And no surprise, when I move the light to off, the light goes off. When I move the light to on, the light goes on. Now there's an interesting thing going on with this circuit right now, in that we can eventually add buttons into this, but I haven't taught you yet how pull up and pull down resistors work to solve a problem we have here. And the problem is that we need each of these things to either be +5 or ground. But we actually have a third state. Let me explain what I mean. Right now, that is in ground, so the light is off. But when I take it out of ground, right now it's not connected to anything, so what's the voltage on there? We actually call that high impedance. And in this mode, weird things can happen. The circuit can become unpredictable. See that light flicker as I pinch that? Because I'm a little bit of a ground, so things can get weird. But the minute I put +5 volts in there, now it's brightly lit and nothing is going to affect it. But that high impedance mode can make things get a little weird sometimes. We can solve that with buttons, but we haven't learned that yet. So right now, no matter what I do, that light is following my +5 or ground here, ignoring the high impedance. So let's turn the enable line off. Now let's set this to high again. Well, the light didn't go on. That's because when I disabled it, the latch remembers what the value was with this line. So even though I've added +5 volts, it's saying, I don't care, you told me to remember that the light is off. So I'll tell you what, let's put that back to ground. Let's enable the latch again, and now switch to +5. So now the light is on. Let's disable the latch again. And now I put this on ground, but the light is still on. Now that this is disabled, this wire is disabled, this one is being ignored. We have 1 bit of memory there. This circuit remembers where this wire was when this turns off. In fact, let's move it back. We can see the minute I turn it off, it goes, oh, you've been grounded, so it turns it off. Turn it on, off, on, off. So the data's there while we're doing this. But the minute I ground it, I turn the latch off, and now the data does not change no matter what I do. I just told it to remember off. So I'll tell you what, let's tell it to remember on. Okay, now it's on. Oh, getting that weird high impedance state again. On. And now, even though I switch it off, it stays on. So we have 1 bit of computer memory. And from that, we'll build up an entire computer.